All right, hey guys, hope you guys are enjoying this beautiful day. So we're going to talk to you guys a little bit about limiting nutrients, but we're going to do it through a Jeopardy format, which you guys are probably familiar with all through like middle school and high school. But we're going to make it a little more fun. All right, so here are today's contestants. We have a Cornell freshman majoring in bio and society, Juliana Zietvat, and coincidentally also a Cornell freshman studying biology, Diego Burga. So Diego, you're up first. Make your first selection.
I'll take in the lab for 200.
All right. The round mobile algal species shown below that was used in the lab. Diego.
What is chlamydia?
Sorry, no, that's not correct. You're now at negative $200. Juliana?
Actually, the right answer is Chlamydomonas reinhardti.
Yes. Congrats, Juliana. That is correct. The other species that was used in lab was Ankystrodesmus falcatus. It was rod-shaped and it was less mobile. Chlamydia was fortunately not involved in any of the laboratory procedures. And you're now on the board with $200, Juliana. Please make your next selection.
I think I'll play it safe and go with nutrients for 100.
All right, nutrients for 100. An element shortest in supply relative to others that is exhausted first and limits population growth.
What
Juliana?
is limiting nutrient?
Yes, congrats. That was the title of the module, so I don't think we need any further explanation. All right, where to next?
This is so easy. Give me nutrients for 400.
Feeling confident, okay. Nutrients for 400. An analogy used to explain that population growth will be limited by the scarcest resource available rather than by the total amount of available resources. Diego?
What is Liebig's barrel?
Yes, that is correct. So, Liebig's barrel, which is shown on the screen, demonstrates that a barrel can only hold as much water as is allowed by the shortest of its staves, where each stave represents the availability of a particular nutrient. So, as you can see, the shortest one is what limits the capacity of the water. Okay, Diego, you're now out of the hole. You have positive $200. So, where to next?
I'll take impact for 300, Vishal.
Okay, impact for 300 reads, the over-enrichment of a body of water with dissolved nutrients and minerals. Juliana?
I got this one. What is hemocytometer?
Sorry, but no, you're now back at $0. Diego?
What is eutrophication?
That is correct. There we go. So, an excess of dissolved nutrients triggers a flourishing of growth known as an algal bloom. You would see this in an aquatic ecosystem because the water would effectively turn green. And this would result in the blockage of sunlight, which would cause an accumulation of dead plant matter at the bottom of the body of water. So when bacteria start to decompose this dead plant matter, they consume oxygen in that body of water, which depletes dissolved oxygen reserves. And so these are kind of the qualities that accompany eutrophication and an algal bloom. Okay, you now have a considerable lead, Diego, with $500. So please make your next selection.
I'll take application for 400.
Okay. Application for 400. This microorganism was commonly used by ecologists in the 1960s to understand how limiting nutrients affect an ecosystem. Juliana?
What are phytoplankton?
Well done. Looks like someone has been reading the lab manual. Types of phytoplankton that we tested in our symbio simulations included diatoms, green algae, and cyanobacteria. So Diego's lead has now been narrowed to only $100, and we have time for just one more question before Final Jeopardy. All right, Juliana, pick again.
I'll take nutrients for 200.
Okay, nutrients for 200. A nutrient that becomes limiting after the primary limiting nutrient is made more available in an ecosystem.
What is a secondary limiting nutrient?
Yes, Juliana, that is correct. So thinking about this in terms of the Liebig's barrel analogy that we discussed before, the second lowest stave on the barrel corresponds with the secondary limiting nutrient. So if the lowest stave were to be raised to above that second lowest stave, the capacity of the barrel would be limited by the next highest one, and that's why it would be the secondary limiting nutrient. And just like that, Juliana, you're back in the lead with $600, but with Diego close behind you with $500 as we move into Final Jeopardy. So please take a second to make your wagers based on the following final Jeopardy category. All right, keeping in mind that Diego has 500 and Juliana has 600. Please make your wagers. Ooh, okay. So you guys are gonna have 30 seconds to answer the question. Here you go. All right, so those are your 30 seconds. Juliana, can you please hold up your answer first? 1,600 cells per microliter is correct, so you wagered 401, so that would put you at $1,001. All right, Diego, not looking too happy. You also got 1,600 cells per microliter, but you only wagered 500, so that puts you at 1,000. So congratulations, Juliana, you have won by $1. Sorry, Diego, better luck next time. Let's give it up for Juliana. So yeah, I'll just put up the answer and explain really quickly because it was a lot to take in 30 seconds. They're just super fast, not scripted or anything. So yeah, you take the 5 cells, you divide them by that volume to get 800 cells per microliter, and then you adjust the ratio with the optical density to get your conversion factor. Okay, so that's all we have for today. Hope you learned a thing or two about limiting nutrients. The knowledge and skills that we learned have applications and implication for the environment, aquatic ecosystems, and future scientific discoveries in agriculture, aquaculture, and biofuels. While this topic may seem simple, we have merely scratched the surface. So hope you enjoyed.